So yesterday we did adding radicals. Today we're going to do multiplying, which I think is actually easier than adding. So that's pretty sweet. It's the exact same again as multiplying polynomials and arc square roots, so just regular letters. So we're going to do a little bit of practice about how do we multiply polynomials. How do we multiply variables against each other? So this first one, remember you need to take that, and you need to take this, and distribute the entire thing to every term that is inside the brackets. I hope that you look at that and you see there's two terms. That's term one, all of that is one term, and all of that is the second term. I know that there's more parts to that term, but because they're multiplied together, it all just makes up one term. Okay, so this first piece, we're going to put it in there. The 2 multiplies with the 5 to give you 10. The x multiplies with the x to give you x squared. The y cubed times y, what does that give you? Y to the power of 4. Remember, you add your exponents when you're multiplying. So y to the power of 4. Then we're going to subtract. 2 times 2 is 4. The x times the x squared will give you x cubed. We add our exponents. And the y cubed times, there's no y's. So it stays y cubed. Can we combine those? No. Why can't we combine them, Jacob?
There's 3x's there and 2x's there.
Hang on. Yeah, the exponents on the x's and the y's are different. What if, crazy world here, this was actually y to the 4th, so now our y's are the same. Can I combine them now? No. The x's also have to be the same. So you have to have just as many x's in both and just as many y's. They have to be the exact same. Okay, that was called a monomial times a binomial. One term times 2 terms. These ones are binomials times binomials. 2 terms times 2 terms means you FOIL it. So we remember to FOIL from the good old days. That's first, outside, inside, and last. So the first terms are there and there. They multiply to me. 2x times 3x. 6x squared. That's our first. Our outside terms. Those would be these ones. 2x times negative 4 would give you negative 8x. Well done. Inside is 5 times 3x. 15x. The outside, 5 times negative 4. Negative 20. Are we done? No, we're not done. If you look at this, we have an x squared, then we have an x, and then no x's. The x in the middle can combine. They need to simplify. So negative 8x plus 15x would work out to give you positive 7x. Everything else stays the same. We had a teacher when I was in high school. They tried to do an advanced math program, so they wanted to take their grade 9s, and then they tested us, and they tried to push us through math quicker. So it was kind of cool, and we started doing this stuff right off the bat. And I was like, that's what we learned in grade 9 right off the bat, was this foiling business, which was mayhem to me. My math teacher was this genius, ex-engineer, smartest guy, and he said you had to do these in your head, like automatically. And he didn't like me because I was a bad person. That's okay. And he knew I couldn't do them in my head fast enough. So he would always force me to do it in front of the whole class. It was the worst experience ever. He'd be like, my name is Matthew. He wouldn't call me Kennedy. That'd be weird. Hey, Kennedy, get up here. And then he'd foil this in your head. And I would just be like, oh, no. And then I'd probably throw a fit and leave the class. Sure. Anyway. Whew, it's like therapy in here. Good. Do the second one. See if you can do it yourself. In your head. In front of the class. No, I'm kidding. Write it on paper. Do the second one. I'll write the answer on the board. I can do them in my head now. Mr. Wild. Shout out. I can't. I still look at it. I still think about it.
Did you eventually get it?
Oh, yeah, I did. I think that's the answer, but I don't know. So do my head. See if you can think.
No, girl, that was right. That's right. No, you messed me up. No, come on.
I got it. Try it, guys. Try it again. Make sure you can get this. Foiling isn't working. We need to fix it because it's only going to get more complicated when sugar radicals.
Don't worry, Mr. Kennedy. I did it.
There you go. He's actually, Mr. Wild is actually one of the reasons I became a teacher. He's actually a great guy. But I'll never forget that.
Mr. Wild?
Mr. Wild, that's his name. Great teacher. Awesome teacher. Just torment. But I deserve it. Did we get that?
Yep.
Are we good? I see some people still working away, that's fine.
What do you think Mr. Wild would say to you if he knew that you were a math teacher?
He knows I'm a math teacher. I'm from Airdrie, it's called town, so I worked at a car wash and he showed up there one day. And we talked when I was in school. Him and I got along great. He's actually a great teacher. Okay, moving on. First one, you should be able to do on your own. Second one, we're going to talk about. So do the first one on your own. Check your answer. See if you can get it. He's actually a good basketball coach. So best high school senior girls basketball coach in Alberta. Nice.
It's 9x squared. That's pretty easy. No way, Mitchell. Yeah. Well, it's different squared. Yeah, it is. There's slow flow. I think it's 29.
Take a shot at the second one. If you think you know what to do with the second one, take a shot at it. Voice in the front. If we look at this, what we have here is a big old binomial squared. What does something squared mean? So if I told you you had 2 squared, what are you really doing? 2 times 2. You're times it by itself. So squared just means it by itself. And what it is 4a minus 5b. So you get rid of the squared and it gives you another one of these. So now you have a binomial times a binomial. And you should do the same thing. You should multiply it out using FOIL. This one's going to get a little tricky because we have 2 variables, so we're going to do it together. 4a times 4a gives you 16a squared. That's the first terms. Now we're going to do the outside terms. So outside to outside. 4a times negative 5b should give you negative 20ab. A and B can't be brought together, so you just leave them as A, B. Next thing in FOIL, inside. Negative 5B times 4A. Another negative 20B. Or, sorry, 28. Does it matter? Does it matter if you
Yeah.
saw your answer as 20BA?
It matters.
Doesn't matter. So order doesn't matter when you're doing multiplication. So if you had A times B, it's the exact same thing as B times A. You switch around, it's okay. The last one. Negative 5B times negative 5B would give you positive 25B squared. Just in case you didn't know where that came from, that was last. That's last. Can you combine any terms here?
Yes.
Yes. Which one can you combine?
20
The 20 ABs. So they should combine to be negative 40 ABs. The other two, you can't do anything with.
I have a question.
Yep.
You want the 45 and 48?
Oh, that's a great question. So,
Because that's what Sean always makes up.
yeah, that's important. We're going to talk about it. Some teachers really want you to have the highest exponents first. So, some of you were saying Shaw would have written it like this: 16a squared plus 25b squared minus 40ab. That's how some of you were taught how to do it. That's fine. It's the same answer. All you've done is move them around, and that's okay. I prefer that what you do is you take a letter with the highest exponent. I'm going to use A because A and B both have squares. And then work your way down from the A's. So the next lowest A would be this one, and then the next lowest A would be this one because there's no A's. So if I had like an A to the power of 5, and the next highest thing was Y to the power of 3, I would choose A's to go first and then work down according to the A's. But it doesn't change it, correct. As long as you remember to move the symbol with it, so the negative has to stay with the 40 AB.
It's not like we did the guys after that. I remember completely changed it.
Oh, and we'll get to factoring. That's what you're saying. When we get to factoring, the way that I factor, I want it in this method. But when we get to factoring, that'll be a whole nother thing. Yeah, but that's a good inkling to where we're headed. Okay, here's a really nice drawn out example of what multiplying radicals looks like. It's not that crazy. As you see, they've given you an example where it's a binomial times a binomial. And they did it the exact same way. They FOILed. So they took this one and they multiplied it by the entire term by itself. Well, they didn't, but they expanded it. We could FOIL them and do the same thing. Does anybody use this method, or do you all use
Or the box.
This is, or the box that is on it. This is just called expanding. So what they did was they took this entire term and they multiplied it by both things. So that's what it is right here. This times both things. See how they distributed it next? Fancy way of doing it. You can do it the same way. The point that matters is right here. I'll circle it in blue. They did 2 root 7 times 3 root 7. 2 times 3 gave them a 6. And then root 7 times root 7 gave them 7. Sorry, this second part actually comes. So I'm going to circle like this. See how those connect? The root 7s, because it's root 7 times root 7, the root sign cancels itself out. So there's just a 7 left. And again, if you're wondering why that works, you could do, how did we prove this yesterday? Root 7 times root 7. That's the same thing as saying 7 to the power of 1/2 times 7 to the power of 1/2. I hope you all know that's the exact same thing. That's just an exponent rule, right? What do we do when we multiply exponents? You add them. What's a half times a half? It's 1. These two See how the exponents just go away when you multiply roots? Same thing happens over here as we see 2 times root 7 times 2. The root 7 is not going to have anywhere to go. So it's going to stay there. 2 times 2 is 4. The root 7 has nowhere to go. So the 4 is right here. The root 7 has nowhere to go. So it just stays there normally. Same thing happens again here. 4 times 3 is 12. The root 7 has nowhere to go. 12, root 7. The last one, 4 times 2 is obviously just 8. It's not that hard. It's the exact same way you're doing polynomials. And unlike adding and subtracting, this stuff isn't going to take like a crazy jump in difficulty, the way that our adding and subtracting questions do. These stay pretty much at this level. The only thing that's going to happen is there's going to be more terms, and then maybe at the end they ask you to simplify your radicals. Nothing too crazy. We'll do a couple together just so you get a look at what it looks like. This first one, I'm going to use FOIL because that's what I think we're all comfortable with. FOIL means, let's do, I'll work my way through the colors. First things multiplied by each other. If I have 2 root 3 times root 3, what am I going to have left? 2 times 3. So 2 times 3. I'm going to write it out slow. You're right, it's just 6. FOIL. So we've done first. Now let's do outside. 2 root 3 times negative root 2. Now we're lost, right? Because we have something underneath the root sign that's not the same thing. So this is what I'm going to show you to do. You're going to go negative, minus 2, because we couldn't do anything with that first 2. What happens when we have root 3 times root 2? Got it. Got it. It's just root 6. So if we put that down over here, we have root 3 times root 2. That's way back at the very original thing that we did in this unit. Root 3 times 2. It's just root 6. It just all links back to another lesson. It's going to keep doing that. That's from the very first lesson. It's linked back. Okay, let's look at the inside terms, because that was outside. The inside terms is 3 root 2 times root 3. What are we going to get? 3 root 6. Yeah. We're going to get plus 3 root 6. And lastly, we got 3 root 2 times negative root 2. So we should have negative 3 times 2. The root signs cancel each other out. Remember, the 2 is just going to stay as a 2. When I use all those colors, does that make it more confusing or more clear where things are coming from? Or does it make no difference? It makes it clear where everything's coming from? Okay. I'm never really sure. I really like the way that it looks so you can see where each thing came from. But I also look at it and sometimes go, that's just like chaotic. Just 4 different, it's like rainbow now. Okay. Can we simplify this? Absolutely. What's the first thing we should simplify? Why not the 6 and the 6? It doesn't matter where you start. Yeah, 6 and the 6. Because 2 times 3 minus 3 times 2 is going to end up to be 0. That's just 6 minus 6. The inside terms, can we simplify those? Yes, because they're both root 6s. So if they're both root 6s, what happens, Chase? Yeah, it would be just, so we have 3 root 6s, and then we have subtract 2 root 6s. So we should just have 1 root 6. Right? They're not, they're... Yeah, if it was a binomial, it would multiply together, but it's separated by a plus sign right there. So we add them together. I see what you're thinking. All that work just to come up with roots. Hi.
There's another one of those was something.
Yeah.
When,
You get a cube root of a regular root. So like if we multiplied roots, you're saying are going to be like multiplying roots, are they ever going to become like cube roots and fourth roots and stuff like that? No, I don't think we'll ever see that. I don't think we'll see our roots multiplying off to be cube roots, fourth roots, and stuff like that. You should be safe. Yeah, for sure. So the black line is the first term, so we FOIL. We did 2 root 3. I'll write it up on the top here so that it's clear. 2 root 3 times 2 root 3. That's what we did, right? It's all just multiplication. So you can do 2 times 2 gives you 4. So these 2's can be connected. And then these root 3's can be multiplied together. What's root 3 times root 3 going to give you? Just 3. So if you have a square root of something times the square root of the exact same thing, the square root just cancels itself out. So root 3 times root 3 gives you just 3. So this works out to be 4 times 3. I'm going to show you one other way of looking at it. This might help. Rather than connect it like that, we can reorder it because it's multiplication, right? So let's reorder it. 2 times 2 times root 3 times root 3. We could reorder it like that. Still the exact same thing. 2 times 2 is 4. Root 3 times root 3 is 3. The root signs will cancel each other out. Just. Smart guy. Thanks, Josh. Yeah, well, no, because this one over here, yeah, it would be a 2. Yeah, you're right. So it would be 4, 8, 12 minus 6. It wouldn't be 6 minus 6. Yeah, sorry, Josh. Thanks for catching that. We missed that. No, Josh, you had it right. It's 2 root 3 times just root 3. It's no other 2. This term is different. Yeah, we had it right. We had it right the first time. It is a 2. It is a 2. Josh, that's good.
So you left stuff out there then.
What happens when you multiply just enough?
Okay, we'll see examples like that. Just number times a radical. Yeah, we'll get examples like that coming. Okay, B, do it on your own. See if you can get the same answer as me. Oh, if you have root 3, sorry, I didn't realize we were running into it right now. I thought it was the next slide. Okay, we'll do this one together because we run into root signs not times anything else. So, we're going to FOIL. First, that'll give you 4 root 3. 4 just first, outside. You have 2 root 3 times 5. 10 root 3. Yeah. The root sign's going to stay off on its own. The 2 and the 5 can be multiplied together. So the 2 times the 5 gives you 10. So it'll be plus 10. And then the root 3 will still live. It lives. On the inside, negative 5 times 2, negative, 2 root 3. 10 root 3. And last, negative 5 times 5 is just negative 20. Oh, that was weird. Is everyone cool with this? Did we get to a spot they're happy?
I have an unrelated question, but okay. Is your ski jump here for speed? Just like okay.
We have actual math questions. Aaron. Yes. So you have, yeah, you have 10 root 3, the red term, and you have negative 10 root 3, the green term. Imagine those root 3s as x's, right? 10x minus 10x. Cancel each other out. Yeah, the root 3s will cancel each other out. Any other questions?
So then you go.
What's your answer? Good question. It'd be 12, cancel, cancel, minus 25. So your final answer is negative 13.
If you go
12 minus 25, negative 13.
Okay.
Okay. Now we're going to go ahead and put variables underneath the root sign. I can't hit what? Just kidding. There's too much talking, guys. People are actually trying to focus on real questions, and it's just too much. We did this question. It's not any harder. We're going to follow the exact same rules. First, 3 times 4 will give you 12. Root A times root A, root signs cancel out. Okay, so it's just going to be 12A. That's your very first thing. That's your first, your outside. You have root 3 times root A times 5. The root A is going to be by itself. And then 5 times the 3 gives you 15. So it's plus 15 root A. Our inside term. We've got negative 2. We're multiplying by 4 root A. That'll be negative 8 root A. And then our last term, we've got negative 2 times 5. So it's just going to be negative. If you look at this, something simplifies. What simplifies? Jason got it. The two middle terms. The 15 root A and the 8 root A are the same thing. They're both root A's. So if you have 15 root A's and you subtract 8 root A's, you have 7 root A's left. The 12A never changed. And the negative 10 never changed. That's it.
Oh, that's so nice.
Okay, so you're thinking, like when we do our negative 2 times our 4 root A, Ty? Ty, like that part?
Yeah.
Okay, imagine this as if it was, right, because that's what they are, they're two separate things. The 2 was over here, the 4A was over here, right? If this was just negative 2 times 4x, what would you do? Negative 8x, because just the coefficients would multiply together. The x would just be with it, right? It's the same idea here. This root A is like a variable. It's like x. It's its own thing. So the coefficients are going to multiply together, and that's bringing your term in. That's combining the terms. There's only 2 terms here. Negative 2 and 4 root A is its own term. Yeah, Austin. Right here. Can we combine them? We're not able to combine them because one of them's a root and one of them isn't. And so, again, if you think of it as root A is really just a to the power of 1/2, they're different exponents, so you can't combine them. That's a really good question because that's a really, really common thing. people want to combine root a's and a's, but you can't. Think of root a as a to the power of 1/2. They're different exponents. You can't combine different exponents. Don't you see the question?
I'm not sure. Thinking about it in my head, I'm just like, it doesn't make sense to me. I was gonna say, what if that -2 was and had an A beside it? And would it change the
It would change lots of things. Yeah. It would change a lot of things. Awesome.
Okay, so times whenever the roots combine, having the cancels.
Yeah, as long as what's underneath the root is the same thing. They both have to be a's. It couldn't be an A and a B. Yeah, you're good. Okay, this next one, they threw it at you. It looks hard. It looks intimidating. It's not.
So, it's like this big.
Is it tiny?
It's like this big.
It looks intimidating. It's not. It's just a binomial times a binomial. A binomial times a binomial. Try it on your own. See if you can do it. I'll write the answer and then combine them all together. Yeah, it's simplified. Write it on the very back page or something. There are 8 pages. It's covered. Get a scrap piece of paper. Write it somewhere. Give it your best shot. Let's see if we can do this one. I see what you're saying. Okay, I'm going to start with the first one. You guys are, as I'm walking around looking, you guys are getting really good at the foiling part. Root x to root x is just your outside. Root x times 2 root y should give you plus 2 root x y. So remember, root y times root x times root x y. Nope, doesn't matter. So if you put yx there, that's cool. Same thing. Inside, we have -2 root y times root x, so it's going to be -2 root xy. A good rule of thumb when you're doing these is go alphabetical order. That's how you're going to see it on your answer keys and in tests. So if it's like a times m times y, they're going to go a m y and stuff like that. It's not wrong to say y a m, spelling m, but that's not how you're going to see it. Because they'll go alphabetical. Okay, last one. -2 root y times 2 root y. -2 times 2 will give you -4. And root y times root y gets rid of the roots. These inside ones cancel. 2 root xy minus 2 root xy, they go away. They cancel each other out. So all we're left with out of this first one is x minus 4y. Going around the classroom, pretty fantastically done. This one over here, also very happy to see that we remember that it's a binomial times a binomial and not to distribute that in. Good job. So this is actually just 3 root x plus root y. I think almost everybody did that. That's a good thing to do. Okay, let's try it out. So, we'll do blue just so we can kind of see. 3 root x times 3 root x gives me 9x. Outside terms, 3 root x times root y gave me plus 3 root xy. Inside terms, another 3x times another root y is going to give me another plus 3 root xy. And our last thing, root y times root y is going to be plus y. And it goes up. Again, you guys did a good job. You simplified this properly. You recognize that 9x can't simplify with anything. The y can't simplify with anything, but the middle two can. 3 root x times 3 root x. Yeah. So you guys got really good and got to this point where it was 9x plus 3 root xy class. And I'm a firm believer that when we come into math class, we're scared of math. I'm a believer that that's the thing, that there's people who stress about math. So when they come into math and they do these questions, they're convinced that it's got to be really hard. So they convince themselves they always have to do more work than they really have to do. And when you look at this right here, it looks really hard, and it's math, so we must have to do something really hard. But we don't. Oh, there. Yeah, Jason.
How does 3xy plus 3xy equal?
Oh, it's 6.
Yeah,
Yeah, thank you. Thank you. But you guys look at this and you think there's something fancy you got to do, but there's really nothing you have to do. It's really simple. When you look at this first thing, we're doing bed maths. Start with inside the brackets. Can you simplify anything in those brackets? No, so now the brackets can go away. You've dealt with the brackets. What about these brackets? Can you simplify anything in them? No. Now you've dealt with them. The brackets just tell you do everything inside the brackets first. Once you do everything inside the brackets, they go away. And sometimes that means they can just go away. So now all you have is a really, really long x minus 4y plus 9x plus 6 root xy plus y. That's all you have. It's just a really long statement. All addition, all subtraction. You guys have been doing this for years. What can go together? Like terms go together. The x's can go together. 9x and x can add to be 10x. What else is a like term? Well, we got a y and we got another negative 4y. So we can go negative 3y. And the very last term can't go with anything. Plus 6 root xy. And it's crazy because this is a hard question, and we do all the hard work right, and the easiest part of the question we get wrong, which is crazy. But it makes sense because we hype ourselves up. Austin. Nope. As long as it's a minus 3y. Aaron. So right here, what's 6 root xy? Yeah. It just states it. Yeah, that's my answer. Right, and that's what I mean. So, like, we're getting to this point, and it doesn't even feel like a right answer because it's still such a mess. It's the right answer. You guys are doing really, really well. Like, you're doing good. Austin. Yes, sir. Don, do you have a question? Are we going to factor radicals? It might come at you at some point. Factoring radicals, again, it isn't that hard if you just imagine it as right? Radicals are just variables. Just imagine it's variables. Okay, I'm going to one more question on that page, right?
Yeah.
Okay. There's nothing fancy with that last one. That last one, you would have normally done by yourself.
What about the root 3? You just add that into
It just multiplies it, yeah.
So it becomes root 6.
It'd be 7 times.
Oh, go already.
Right. Okay. This is the last question we'll do because we're going to see the same problems as that other one. We'll do this one as a group, and then I'll try to give you guys some time to actually. What's up? This road is going. Okay. The very first thing you do, in my opinion, is you take that negative and you distribute it in. If I don't distribute that negative in, I know I would forget it. It would eventually just drift off into the land of social class or something. Like it would go away and I would lose it. So I'm going to distribute it in. What I mean is this negative right here, I'm going to distribute it to both things inside the bracket. So this question's really going to be negative 3 root 2 minus root 5.
Plus root two.
Plus, yeah. Good catch, Jason. Yeah, that'd be the first one. You could theoretically not do that and then wait to the very end and change things, but I promise you that that would probably mess you up at some point. So just deal with it now.
That's the hardest part of this course.
Legit, yeah. Okay. We're foiling. First terms, right there. What's negative 3 root 2 times root 2 going to be? Negative 3 times 2. That's our first term. Outside term. We have negative 3 root 2 times 7. That's going to be negative 14 root 2.
21.
Oh, 21. Yeah.
Oh,
I have a little bit of like this. What is this? It's actually what it is you're talking like saying numbers while I'm writing other numbers.
oh, I don't like that.
Twist your brain around. Inside, root 5 times root 2. Do those root signs cancel? No. Yes. No, they don't cancel. Why don't they cancel? They're not the same. 5 and a 2 are not the same.
I would've been there.
So all you're going to have is plus root 5 times 2, so 10. Remember back a couple lessons ago when you have a root sign times another root sign, you can multiply the two things together. So 5 times 2 is 10. Finally, your last term. Root 5 times 7 is going to be plus 7 root 5. Okay. Crazy. Okay. Now, I'm going to keep going at one fluid motion. So, we have all of that in one set of brackets.
So if you don't,
Now we have, oh, yeah, go ahead.
so because like none of them are like the same, it's all like that.
You got it. Yeah. That's what you can do. The first one has no root signs. The second one's root 2s, so that's useless to us. The next one is root 10s. Nothing to do with that. Next one is root 5s. Nothing to do with that. What you do need to ask yourself, though, when you're looking at these, and if none of them match up, is can I simplify any of them? Does that make sense? So could I, for instance, root 12 to be broken down into root 4 times root 3, which should be 2 times root 3. That's from a couple days ago, too. And that might pop up. That would be an advanced question because it's mixing so many topics. That's not what we're going to see here. Okay. This second part is going to be minus. And in brackets,
Can you just,
we have,
Just change the sign to.
yeah, you do that right away.
you can't. You cannot. Because it's got to be your brackets first, which has that exponent on it. Yeah, that's a very good point. That negative is going to be, it's almost as if there's another set of brackets right here after we do this. Right? Right. Sorry, it looks more like this. Bracket. It's almost like that, and we're going to solve inside first. Yeah.
It's, that would be multiplying. Then we
Right.
gotta do this.
Yeah, distributing, that's a good way to look at it. Distributing that negative 1 in would be multiplication, which is bed mass comes after the exponent. So that's a good way to look at it. Okay, so minus. Our first terms multiplied together are going to be 4 times 2. So I'm just going to put 8. That's our first terms. Our outside terms, 2 root 2 times root 5 is going to be negative 2 root 10. are inside. We have negative root 5 times 2 root 2. That's going to give you negative 2 root 10. So the same thing. Sorry, that would be positive. Because it's a negative times a negative, right? Which one did we do? No, sorry. I was doing my outside. Yeah, it's negative.
Yeah, tell us. Just positive. Start positive.
Yeah, I did my outside. Aaron's asking, can we just combine them? Yeah, you can just write it right now as negative 4 root 10. Like, you can combine them right now in your head, Mr. Wild stuff. So I'm going to call it from now on. He like, was dead set on, you need to be able to add them together in your head every time. Your last one, root 5 times root 5. They're both negative, so it could be positive. Liam. Oh, no. Because imagine if it's an x, right? So it would be like 2x minus 2x would still be negative 4x. The x would still be there. The root 10 would still be there. Yeah. Okay, this first thing, we never changed any of it, so I'm going to write it all out again. So, negative, change it to negative 6 minus 21 root 2 plus root 10 plus 7 root 5. Okay, that's our first part of the question. It's never changed. The second part of the question, we can't just get rid of the brackets yet. Why not? Because of the, you can combine the two in the middle. Because we're minusing. Aaron's right. We have to distribute that negative in before we can get rid of the brackets. This negative right here, the one I'm going to underline in red. This guy right here. He's ruining things for us. He's the one that doesn't let us just get rid of the brackets yet. We have to distribute that in. So when we distribute it, it becomes a positive. And then everything else flips. So it will become negative. We could have combined the 5 and the 8, right? So it would have been 13. So we have negative 13. And we have positive 4 root 10. That 13, I just combined my 5 with my 8. It'd be 13. And then switch the sign. Here. Now we can. Yeah. Okay. So, look at this. BEDMAS, brackets. Is there anything we can do inside the first set of brackets? No. So we've dealt with them. Go away. Second part. Brackets. Anything we do inside? Go away. Now it's a simple addition subtraction question again. Negative 6 and negative 13 is going to give you negative 19. Because we changed that sign to a positive, right? So it's like plus 8. Oh, yeah. Negative 21 root 2. Can't do anything with it. Root 10. Can we do anything with those? Yeah, what can we do? Find it over here. So we have plus 5 root 10. And the very last one, root 5 all by itself, can't do anything with it. Wait. Crazy question, right?
Takes crazy forever.
Takes crazy.
I would actually enjoy it, Mr. Well, because I had people